This lesson is on limits. Our learning objective: given a function, students should be able to find the limiting value graphically, algebraically, or numerically by using Excel and interpret the meaning in the context of the problem. So we're going to look at finding a limit in three ways. We're going to look at it graphically, and then algebraically, and then numerically. So today we just want to work with graphically, and we have a couple of things here. First of all, if the limit does not exist, we'll write DNE. So DNE stands for does not exist. Also, if the limit does not exist, it might be heading toward positive infinity, so we'll use plus INF, or if we have the ability, we'll put plus and then this is the infinity sign, or negative INF or negative infinity. So those are abbreviations. The limits don't exist, but sometimes if they're heading toward positive or negative infinity, we'll indicate that as the type of way that they do not exist. So before calculus, we had maybe a problem like this: f of x equals x squared minus 1 over x minus 1. And we might ask, where is this function discontinuous? And so you would look at the denominator, or I might ask, where is there a restriction on the domain? So you would look at the denominator and say the denominator cannot equal 0. So when x is 1, you get 0 in the denominator. You also get 0 in the numerator, but I want you to remember that if you get 0 over 0, that's not a number. 0 divided by 0 is not 0. 0 divided by 0 is undefined. So we would say that if you let x equals 1, this function is not defined. It is undefined. You can put any values in for x and evaluate and get a number except for the number for x equals 1. You can't put that in for f of x. So 1 is outside the domain, and this function is undefined when x is 1. Alright, here's an informal definition of a limit. If f of x becomes arbitrarily close to a single number L as x approaches a number c from either side, the limit of f of x as x approaches c is L. This is the notation. LIM stands for limit. So the limit of the function, the limit of f of x as x approaches some number c equals L. So what that means is if you have a function and you approach it from either side, that means from the left side. So let's say c was 2. If you get really, really close to 2, like if you let x be 1.8 and then 1.9 and then 1.95 and then 1.99, and you got really, really close to 2, if you evaluated that function, it would approach a number L. And then if you looked at it from the other side, from the right, let's say if c was 2 and you looked at 2.1 and then 2.05 and then 2.04 and 2.03 and got really, really close to 2, the function would approach that same number. So if you're looking at a function and you're looking at a number like 2, as x gets really, really close to 2 from the left, it'll approach a number L if the limit exists, and if x gets really, really close to 2 from the right, it'll approach that same number L. And if that's the case, then the limit of f of x as x approaches c is L. So let's look at a graph. And here's our same function. F of x equals x squared minus x divided by x minus 1. Here's the old way we evaluated. So f of x equals x squared minus 1 over x minus 1. Well, x squared minus 1 factors. That factors into x plus 1 times x minus 1 over x minus 1. And then notice that the x minus 1's here, they cancel, and this leaves us with the function f of x equals x plus 1. But remember, before you do any canceling, you have to notice that x cannot be 1 because you can't have 1 in the denominator. So this function is equivalent to f of x equals x plus 1, except x can never be 1 because at 1 the function is undefined. So remember, that means that there's a hole at the point 1, 2. And I get the y coordinate 2 by putting 1 in, and 1 plus 1 is 2. So here's the graph of y equals x squared minus 1 over x minus 1. It looks like a line, y equals x plus 1, except there's a hole right there at 1, 2. So this function is undefined when x is 1, and there's a hole when x is at the point 1, 2. Over here is what a limit looks like. So we have the limit of f of x as x approaches c equals L. Let's use this function here. So the limit as x approaches 1 of x squared minus 1 over x minus 1. Notice what you do. You do the same thing. You're going to factor the numerator, and then again you can cancel out the x minus 1 or the x minus 1. And so this function becomes x plus 1. And the limit as x approaches 1, if you put 1 in, 1 plus 1 is 2. So the limit as x approaches 1 of this function is 2. Now, what's the difference? So remember, the definition of a limit is as x gets really, really, really close to 1 from the left. So I'm getting close to 1 from the left. It's not when it is 1, but when it gets really, really, really close to 1, it's approaching the number 2. And then again, if I look at as x equals 1 from the right, as it gets really, really close to 1, it seems to be heading right towards that 2. So even though it's undefined at 1, the limit of the function as x approaches or gets really, really close to 1 from both directions is 2. Let's look at another graph. Remember that the value of a function and the limit of a function are two different ideas. So here's a function. It's increasing, increasing, increasing. But when x is 2, the value of the function is 1. See that point? However, the limit of f of x as x approaches 2 means as it gets really, really close to from the left, where does this function appear to be heading? Appears to be heading right to 2. And from the right, as x gets really, really close to 2, where does the function appear to be heading? Here, right, 2. So the limit of the function as x approaches 2 is 2, not 1. That's the value of the function when evaluated at 2. So the limit of the function refers to the value that the function approaches, not the actual value. Let's look at another one. Let's see if we can look at the notation here. So the same example. So when I was approaching the limit of the function as x approaches 2 from the left, you see this little minus? That minus is on the right side of the 2, so this means as x approaches 2 from the left. You see this plus here on the right side of 2, that means as x approaches 2 from the right. So that's the notation. And for limits, if you want to find the limit as x approaches 2, you have to try it from the left, try it from the right. And if from the left and the right you get the same value, 2 in both cases, then the limit exists. And so the limit of f of x as x approaches 2 is 2. Okay, here's another example. So we're looking at x equals 1 to start, and this is the limit of this function as x approaches 1 from the left. That means you start over here, and as x approaches 1 from the left, the y value is the actual graph that I'm following. It appears that the y value is approaching 0. So that's what we call the left-hand limit. Now if I approach 1 from the right, then that's over here, and so the y values are here and here. I'm getting closer to 1 from the right, and from this side, as x approaches 1 from the right, the value of the function appears to be 1. Okay, so if the limit as x approaches 1 from the left is 0, and as x approaches 1 from the right is 1, that means that this limit does not exist because the left and right hand limits do not match. And then again, this is a different notation. This is asking you to evaluate the function when x is 1. So when x is 1, the y is not 0, there's a hole there. Y is 1. When x is 1, y is 1. Okay, look at another example. This time we're looking at x equals 2. The limit of the function f of x as x approaches 2 from the left. So here's 2, and we want to approach it from the left. And as we approach this function from the left, it's heading right towards 1. So the limit as x approaches 2 from the left of this function is 1. From the right, the limit as x approaches 2 from the right is also heading right towards 2. It's not evaluating at 2, that's a different thing, but as it gets really, really close to 2, it's appearing to approach 1. So this limit would exist. So the limit as x approaches 2 is 1, because from the left it's 1 and from the right it's 1. Now remember, this is a different thing. F of 2 means to evaluate the function when x is 2. What's y when x is 2? And for this function, the value when x is 2 is 2. Here are some more finding limits graphically. I found this worksheet on the internet. So there's just a little bit of a notation error. We want to find the limit of the function f of x as x approaches 3 from the left. So to do that, what you're asking is, as x gets really close to 3 from the left, what's the function, or what are the y coordinates doing? So as we approach 3 from the left, we start out up here, and the function appears to be heading to this hole right here. So as x approaches 3 from the left, the function's value approaches 2. We're not evaluating, that's just what it's approaching. And then the limit of the function as x approaches 3 from the right, well, the function is here as we approach 3 from the right, and so as we approach 3 from the right, the function is heading towards negative 2. Therefore, the limit of the function as x approaches 3 does not exist, because for the limit to exist, the values from the left and the right as we find the limit have to be the same. Then f of 3 means to evaluate when x is 3. When x is 3, the value of the function is 1. Okay, let's look at example 2 here. We have another discontinuous function, and we want to find the limit of the function as x approaches negative 2 from the left. So as the x values get close to negative 2, the function's y values approach 2. The limit of the function as x approaches negative 2 from the right also head to 2. The y values of the function head to 2. So since the limit of the function as x approaches negative 2 from the left and the right is the same, then the limit of the function as x approaches negative 2 is 2. And f of negative 2 means when x is negative 2, what is y? And that is also 2. So this is a discontinuous function, but it's continuous at negative 2. It's discontinuous at x equals 0. Example 3, another discontinuous function. The limit of the function as x approaches 1 from the left. Here's x equals 1. From the left, here are our y values, and as x approaches 1 from the left, the y values approach 3. The limit of the function as x approaches 1 from the right, here are the y values of the function, and as x approaches 1 from the right, the y value of the function approaches 2. So since these two limits from the left and right are different, the limit of the function as x approaches 1 does not exist. Then if we want to evaluate f of 1, that means when x is 1, what is y? Well, when x is 1, y is 2. Alright, example 4, this is a nice continuous function. You don't have to pick up your pencil as you graph this. So the limit as x approaches 0 from the left of the function is negative 3. And the limit of the function as x approaches 0 from the right is also negative 3. So the limit of the function as x approaches 0 is negative 3. And if you evaluate when x is 0, y is negative 3. So when you have a continuous function, the limit and the evaluation at that point is the same. Okay, last example. We have this graph. It's a discontinuous graph at x equals 0 and at x equals 1. So if we want to find the limit as x approaches 0 from the left, it's approaching, the y value is approaching 0 as you get really close to x equals 0 from the left. The limit as x approaches 0 from the right is also 0. So the limit of the function as x approaches 0 is 0. Let's move to 1. Okay, we're going to do left, right, and then find the limit. So here's x equals 1. The limit as x approaches 1 from the left is approaching 1. The limit as x approaches 1 from the right, however, y is 0. Therefore, the limit as x approaches 1 of the function does not exist. Okay, let's move to 2. We're going to look at the limit as x approaches 2 from the left, from the right, and then the limit of the function as x approaches 2. So here is 2. X equals 2 here. So the limit of the function as x approaches 2 from the left is 0. And the limit as x approaches 2 from the right is also 0. Therefore, the limit of the function as x approaches 2, since these are the same as 0. And then if you evaluate f of 0, that means when x is 0, what's y? And that would be 1. To finish, on the interval -1 to 1, f of x is discontinuous when x is 0 and x is 1.